Welcome back to the deep dive. Today we have a very focused mission.
A very practical one.
Exactly. We're here to help you, the parent or homeschool educator, bring some structure to the wonderfully chaotic world of construction play.
Right. We're talking about foundation and year one children.
That sweet spot, 5 to 7 years old, where their curiosity just explodes. We want to go beyond just building a block tower and really turn that play into high-value learning.
We know you need a shortcut. I mean, who has time to read through curriculum documents?
Oh, buddy.
So we've synthesized the crucial points. What your child needs to learn about building, about materials, about machines, and at what stage.
The mission today is to translate all those dense educational goals into things you can actually do and say.
Right. So every walk past a building site, every single session with Duplo is a teaching moment.
We're basically giving you the roadmap. So if your child is pointing at everything and asking why.
Why is the road flat? What does that big yellow arm do?
Yeah. Yes. You're going to walk away from this with the exact age-appropriate answer. And maybe more importantly, the reason why that answer matters for their learning down the line.
Okay, let's unpack this. Where do we begin?
We have to start with the foundation level. So that's generally for 5 to 6-year-olds.
And the learning here is really all about fundamental awareness.
Noticing, naming, and purpose. So what's the very first concept a child at this age needs to grasp?
It's about anchoring them in their world. They need to distinguish between the built environment and the natural environment.
Okay, that sounds simple enough.
It is, but it's a huge idea.
Yeah.
It's the realization that the world is made of things that just grew, like trees and soil and things that were put there by people.
Houses, roads, bridges.
Exactly, things made with intention.
So on a walk, the teaching moment is as simple as pausing and saying, see that tree, that's natural.
And see that fence, that's built. It's just a simple observation game.
But there's a deeper concept there, right? The idea of purpose.
That's the most critical insight you can give them at this stage. Everything that is built was built for a reason.
So if they can just say, people build houses to live in.
Or, the road is for cars to drive on. If they can make that simple connection, you've met the curriculum's goal. They're linking a structure to a human need.
That makes perfect sense. They're seeing systems, not just objects. So from the environment, what's next? The materials.
The materials themselves. And again, for foundation, we are keeping it incredibly simple.
Just pure recognition.
Exactly. The goal is just to help your child identify and name the 4 key materials: wood, bricks, concrete, and metal.
And the big takeaway for you, the parent, isn't just the names.
Right. It's the first hint that the world isn't all one thing, that different jobs need different stuff.
And we should be clear. We're setting appropriate goals here. You don't need to explain steel composition.
No, please don't. The sources even say if your child calls concrete cement, that's perfectly fine at this stage.
We can save that distinction for a few years down the road.
Absolutely.
Yeah.
The whole point is to notice the difference.
Right.
Not to understand the science. You just need to be able to say, look, this house is made of wood, but that wall is made of bricks.
And you can tie that recognition directly into play.
Which is where the real magic happens.
Right.
Trial and error.
Moment.
You give them the blocks, the Duplo, sand, whatever. They try to build a tower. What happens?
It falls over.
It falls over. And the learning isn't in the finished product. It's in them noticing that it fell.
And then instinctively trying to fix it.
Right. They'll make the base wider, maybe, or put a heavier block on the bottom without even thinking about it.
Yeah.
That's the curriculum in action.
So the tip for the parent isn't to tell them how to build it.
No. It's to prompt them. You ask, oh, it fell. Why do you think that happened? What could we try next time? You're just giving words to their design process.
And while they're playing with these blocks, they're probably looking out the window at the real thing.
At the big machines. And for foundation, same rule applies. Recognition only.
So what's the core 4 they need to know?
Digger, crane, bulldozer, and truck.
That's it.
That's it. If you're passing a site, just pointing and naming them is enough. The only other idea is the broad one. Machines help people build big things.
You're just establishing the vocabulary.
And a sense of scale.
Okay, that gives us a really simple, beautiful map for 5 to 6-year-olds. Built versus natural, name the 4 materials, name the 4 machines.
And if foundation was all about observation,
then year 1 is about assigning a job title. This is where it gets really interesting.
That's a great way to put it. In year 1, so for 6 and 7-year-olds, the materials they named last year now have specific functions. They have properties.
Can we give the parents a little cheat sheet for this?
Let's do it.
Yeah.
So wood isn't just wood anymore. It's strong, but also lighter.
Okay.
Bricks are now hard and heavy. Concrete becomes the thing that makes everything really strong.
And metal.
Metal is the very strongest. For support, for connections.
So the teaching tip here is to emphasize that connection. Different materials get used for different parts because they have different jobs.
Right. You're starting to introduce the why.
But that brings up a question. If wood is lighter, won't a kid immediately think a wood house is less safe than a brick one? How do you handle that without a lecture on structural physics?
That's a fantastic question. You handle it by focusing on what they can see. You point to the thick wooden frame of a house being built and explain that even though it's light, the shape and how it's all connected makes it super sturdy.
So you're linking what they can feel heavy versus light to what they can see.
Exactly. And that leads right into understanding the parts of a building.
So we're moving from just seeing a house to seeing its components.
Yes. In year one, they should be able to identify and name the walls, roofs, doors, and windows.
And crucially, understand their function.
Right. The roof keeps the rain out, the walls keep you safe, the door lets you in and out. It grounds these big ideas in their own home, their own world.
And this all naturally leads into the big concept for this age, stability.
Which is really just practical physics hidden in play.
So now they need to start actually saying the principles they discovered by accident last year.
Yes. They should be able to observe and say that wide bases are more stable, that a tall, skinny tower falls over easily.
And that a strong, heavy base helps things stand up.
The language you should be using constantly when you're playing is that comparative vocabulary.
Strong, stable, tall, heavy.
Balanced. You're just giving a name to their intuition.
They're becoming little engineers without even knowing it.
And their understanding of the big machines has to level up too.
Right. They know the name. Now they need the job title. How do we make that clear?
You move from the name to the action. The digger doesn't just help build, it digs. It digs a hole for the foundation.
A crane lifts heavy things. A truck carries materials.
And a bulldozer pushes dirt. The construction site becomes this story of interconnected actions.
Which raises a really important question. How do we take those simple job descriptions and get them ready for year 2, where they're going to start asking why?
Why is that machine even necessary?
Right. And to answer that, we need to move into the activity ideas and some of these more advanced concepts.
We need to satisfy the why.
In year 2, they start asking those simple questions that are actually really complex. Why do buildings need strong bases? Why are bridges so strong? You need that answer ready.
And the concise answers are key. Foundations keep the building from sinking. Strong materials are needed for safety. That's it.
You can apply that same simple reasoning to material choices, right?
Absolutely. Let's give some examples you can use straight away.
Okay, let's do it.
Think about roads. Why concrete? The simple answer is that concrete is super strong and can handle heavy trucks.
If you tried to make it out of wood,
It would break immediately. The logic is observable.
and for a house,
Wood is often used for the frame because it's lighter and easier to work with. It's faster to build. You're just providing the benefit of the choice.
not the full economic or engineering analysis.
Not at all. You're giving the compelling why without the technical how.
And this whole reasoning process is what primes them for that explicit cycle in the technology's curriculum.
Design, test, improve.
You can actually formalize this with them.
The sources highly recommend it. When their tower collapses, that's the test. You encourage them to notice what went wrong. The base was too small.
And then change it to make it better. The improvement.
You're just giving them a vocabulary for innovation. It turns failure into data.
Okay, let's go back to the machines for that really curious kid, the one who wants the full picture.
Yeah.
Why an excavator instead of just 10 people with shovels?
The answer is speed and depth. People can't dig as fast or as deep. Simple as that. The simple how is that it uses a huge arm and a bucket to multiply our strength.
And what about the king of the construction site, the crane?
The crane is all about height and weight. Buildings are tall, materials are heavy. People just can't lift tons of steel 50 floors into the air.
So the how is its long arm and the counterweight.
Yes, using physics to fight gravity.
And those essential groundwork machines.
Huh?
The bulldozer, the road roller.
The bulldozer's whole purpose is to push dirt around and clear the site. Why? Because the ground has to be perfectly flat before you can even think about a foundation.
It all comes back to stability.
It always does. And the road roller does a similar job, just compacting the surface to make it safe and durable.
What's so interesting about all this is that while the curriculum tests some of this,
The most valuable learning comes from these non-assessed ideas. The basic engineering principles you can show them during play.
We're talking about demonstrating, not lecturing.
Exactly. You show them, you build a heavy structure on a tiny, thin column,
Nah, watch it crash.
and then you build it on a wide, thick column, and they see it hold. The visual proof is everything.
Visual proof is paramount, and you can tie that visual thinking into another activity.
One of the most powerful and often overlooked ones. Simple plans and drawings.
That's a huge cognitive leap, isn't it? Going from a 2D plan to a 3D building.
It's massive. You're connecting abstract representation to physical reality. Encourage them to draw what they want to build first. A simple sketch of a house, a top-down view of a road.
Before they even touch a block.
Yes, it supports their engineering thinking, but it's also literacy. It's communication. You're showing them how architects and engineers actually start their work.
And finally, we should touch on the social side of it all.
The team behind the build.
Right. It's not just machines and materials, it's people working together.
And the concepts here are simple. You can identify the key roles. Builders putting it together, drivers for the machines, and engineers. And you can define that loosely. Who draw the plans?
The core message is teamwork.
That complex things require different people, each with a specific job, all working together. It's a vital social lesson.
So that really brings us to the end of our deep dive. We've covered the whole map, from foundation to year one.
Moving your child from just naming things.
To understanding their function, their purpose, and even the basics of stability.
You now have that concise framework, block play, walks in the neighborhood. These are no longer just random fun. They're structured, high-value teaching moments.
You're equipped to help them understand how the world around them is actually constructed.
Without ever needing to get bogged down in complex physics or details they don't need yet.
So what does this all mean? It means that the biggest, most complex structures, the skyscrapers, the bridges, they're all built on the simplest, strongest foundations.
And now you know exactly how to help your child build those cognitive foundations one step at a time.
A perfect summary.
And if we want to connect this to the bigger picture,
Oh.
a final thought for you to mull over.
Okay.
Think about the first structures your child sees that are not human-made. A beaver dam, maybe? A bird's nest? A spider's web?
Right.
How could you use that foundation concept of purposeful construction and the year one idea of material function to compare a house to a nest?
That's fascinating. Both are engineered for survival.
And both use materials perfectly suited to their environment. It's just something to explore on your own as you continue this journey with your young learner.
Fantastic food for thought. Thank you for joining us for this deep dive. We hope this has prepared you to tackle the world of construction with confidence. See you next time.